All right, so light on people here this week. It's not even Halloween weekend yet. So anyway, let's kind of do a little bit of a review of some of the major concepts that we talked about from really the previous two classes, right? We're then going to kind of jump into the next thing, to Monopoly. That homework is due at the end of next Friday. I would really start working on that so that procrastinate is going to be covering things that we did 2.5, 3 weeks ago, right? So start trying to chip away at that. You should have the majority of what you need to get through all the problems, especially after today. I'll also put up a Word document that has like some practice problems. So you can start thinking about what we've covered and the types of problems you might see on the next exam that kind of looks like that. So I'll get up a practice problem with an answer key. So you'll have that there as well. Okay. So we left off the last class and we were thinking about perfectly competitive markets, right? So we talked about how we would calculate profits, right? Which another way of thinking about this, we said, was total revenue minus total cost. We could break that down into an equation which would take the quantity that you're selling and then multiply that by however much you're making per unit. Well, how much am I making per unit? Well, I have to take that equilibrium price as given. So that's how much I'm making each unit, right, in terms of revenue. But my per unit cost is represented by average total cost. So the difference between the two would be like, how much am I adding to profit by every unit I sell? Whatever amount I'm adding the profit from every unit, multiply that by the number of units, that gives me my total profit level. We said, how do I determine this equilibrium? Shouldn't call it equilibrium, sorry. This optimal kind of quantity for the firm. Well, this was going to be the quantity where we said marginal revenue is equal to marginal cost. Okay, so this is the profit maximizing quantity. Once they select their profit maximizing quantity, what are the level of profits, right? And then we talked about in the short run, maybe I can exist with some negative profits and minimize my losses. In the long run, we said profits were driven down to what? We had this idea, firms can enter and exit. There's positive profits. Firms enter the market. That increases supply or drives the price down. As the price gets driven down, profits get driven down to 0. If there was negative profits, firms leave, supply decreases, pushing the price up, increasing the profits up to this 0 point in the long run. So if we had a truly perfectly competitive market, which in reality, nothing's truly perfectly competitive, there's always going to be some market power. But if we had a truly perfectly competitive market, everyone's selling the exact same homogeneous product. There's a lot of sellers and a lot of buyers. There's no barriers to firms entering or exiting this market. We're in the long run with no fixed costs. We would actually see economic profits be driven down to 0. Now, today, we're going to see that life isn't always like that, right? So we have market power issues. We'll start with the most extreme first, which is the monopoly. And that's probably the one I'll hammer the most, even next week when we look at the other two. So with a monopoly, this is, there's the game. You've probably heard this used in just like everyday language in terms of if someone's monopolizing something, that means that they have kind of complete power to provide that, right? Or complete power to supply that. So when we think about this in terms of markets, a monopoly means there's only one seller. Okay? So the perfectly competitive markets is that there are a lot of different companies selling this good. There you go. But here we've only got one seller of this good, or one producer. So I'm thinking about my individual supply curves. I added those up to get market supply. With a monopolist, their supply curve will be market supply. Right? They're the only ones supplying the market, so their individual supply curve is the market supply curve. So they have full market power. We can also think about a lot of times, why do monopolies exist? Well, generally, when being a monopoly is a bad thing because they're generating these huge profits and hurting consumers, right? Why don't more firms enter that market if there's positive profits? Sometimes there's barriers to entry, right? So somehow there's barriers to entry, whether or not that's government imposed, or whether or not that's some type of byproduct of just whatever that industry is. Sometimes it exists because of like extremely large fixed costs. We'll kind of think about those down the road, but this is another kind of trait that we see with monopolies. So how do they exist? We've got three really different types. One is a firm owns a key resource, right? You can think about this as who has a monopoly in, the market. This is maybe a shameless plug for my sports econ course, which is in the spring, but I think you have to have 2.1, so I don't know if you guys can take it next spring, but you could the following year. But if you're thinking about, I don't know, Chicago Bears tickets, right? There is one supplier in terms of the Chicago Bears are the only ones originally selling those. There might be resale markets, right? Like StubHub, things like that. But there's one original seller, one original producer of those. Okay? So they own a key resource. Kind of De Beers is another really good example. They own almost all the raw diamond mines. So they're essentially have a monopoly of the diamond mine. So, the other kind of formula we have is usually the government gives exclusive rights. So a really good example of this is the post office, right? And we do have other mail delivery carriers. They were kind of, especially go back 34 years, they were kind of given exclusive rights. Sometimes we see this given to different utilities companies. So like maybe there's only one supplier of natural gas in an area, and that was given to them by whatever that local or state government was. And then the other is natural monopolies, which is just that there's only enough demand given what the costs are in the industry to support one firm, right? So this would be the idea for a long time. It kind of depends on where you live because of the population. But let's say in a smaller city, so I'm like even thinking about much smaller than Muncie, right, where you only have a couple thousand people. To run cable to those areas, there's huge fixed costs, right? So I've got to make sure that I can get all of demand in order to compensate for these huge fixed costs. Right? So if I go in there, I lay, maybe I put up all we're talking about telephone companies, but I put up like the original way back, I ran the lines for telephone. I was a company that did that. And now someone else kind of uses those, what I already put up. Now there's two of us, we both had to pay to kind of put up these huge fixed costs, but we're only getting half the demand. It's not profitable for either of us to be in that market. So natural monopolies are where we're really given the cost structure and the current demand. There's only enough demand to create zero or positive profits for one firm. As soon as that second firm enters that market, profits become negative for both of them. What happens in the long run? One of them's going to leave. Now we're back to one firm. Right? That's the idea of a natural monopoly. A lot of the times, if it's not kind of given to the government, utility companies, we see that a lot. Often electric companies, things that have these huge fixed costs of running their lines. So cable companies will sometimes be natural monopolies. And this doesn't have to be over the entire U.S. You can have a monopoly within a certain region, right? So I might, electric company might be a monopoly Indiana American Electric, there they are in Indiana, monopolize that market. They don't have a monopoly in California for electricity, right? So they can be a region. So there's going to be some key differences between a monopolized market and a perfectly competitive market. Okay. So with a perfectly competitive market, we said really it was almost like demand for their product, or essentially their marginal revenue curve was flat, right? Because they could only take that equilibrium price as given. That's how much their marginal revenue was for every single unit. Increasing, selling more when we're thinking about the perfectly competitive firms, that they chose higher quantities that didn't influence the price of the market because they were such an infinitesimally small amount of the overall supply. Problem is with a monopoly, they're the only ones supplying it. So when they start adding more to the market, right, they're increasing the supply and driving down the price. So purely competitive firms have this constant marginal revenue because that was whatever the equilibrium price was. But with monopolies, their quantity decisions inherently influence the price. Right? But you can essentially think about it as really the monopoly as these marginal costs. So whatever the monopolists' supply curve are, as they add a higher quantity to the market, that's going to influence kind of where we're at on that supply curve, influencing where that equilibrium price might be. So they instead face the entire downward sloping demand curve. And we'll start out thinking about it as though, so they're going to produce a certain output, and that's going to correspond to a price that they can sell for that for in the market. So if I sell 1 unit, sorry, if I sell 1 unit, maybe I can get that person is going to pay $20 for it. So as a monopolist, I actually don't have to, the equilibrium isn't dictated by what supply is demand. It's where whatever quantity decision I'm choosing, right? I don't have to kind of sell a higher number of units if I don't want to. Right? So if I sell 1 unit, the price is 20. If I want to sell 2 units in that market, well, I know there's higher supply now, so I might be able to get less for that. Right? I know that as I increase that quantity, that would result in being able to charge a lower price. Or think about it differently, if instead of choosing the quantity that they sell to the market, if they're going to set the price for the good, as they set lower prices, they're able to sell a higher quantity, right? They're just moving along this demand curve. So they face this downward sloping demand curve, and the marginal revenue, you kind of imagine, well, my price is now changing, so it's not constant. So what is marginal revenue going to be? So we'll look at some numbers to understand it. I'll then try to give you a visual and connect to something we've already talked about. So just different ways of looking at it. So I think this might be the easiest to not get too often like the graphs. So let's say we've got some coffee shop and they're selling cappuccinos. Doesn't matter what we're kind of thinking about. And they've got, this is a small 2,000 person town. And it's the only place in town, right? So they monopolize the market in that town. Okay. So they know that they can choose to produce these different quantities, or like I said, if you want to think about it as they can set the price for these cappuccinos at these different amounts, right? By setting the price, they would inherently kind of choose the quantity. If they chose the quantity, they're inherently choosing the price. Doesn't matter which way we think about this. So what's total revenue? Well, total revenue, I think I meant to say this at the beginning as well, but this was just price times quantity, right? So total revenue is just price times quantity. So how could I calculate it here? Well, if I set the price at $4.50, nobody in town is going to come buy coffee from me. So I get $0. If I sell it for $4, I'm selling only 1 cup in town. So 1 times 4 is 4. If I lower the price at $3.50, I can sell 2 cups. So my total revenue would be 7. So on and so forth. Right? So I can kind of see that as I'm choosing these different prices or choosing these to sell kind of a higher quantity, that's going to impact the total revenue that I can make. Now, my costs were 0. This is easy because at this point, what price do I want to set here? Actually, I'm indifferent between 2 prices. Yeah, if I had 0 costs, I only would care about revenue, right? I would kind of get rid of that total cost from my profit equation. Well, total revenues are maximized down here. Now, the problem is I do have costs, right? And my costs are increasing as I produce higher number of units, right? But for now, we'll just think about we got this total revenue. I'll then want to calculate 2 additional things, right? So kind of show you where does marginal revenue come from for the monopolist. It's not this flat curve anymore. So as I decrease the price or increase the quantity here, my average revenue, right? I will take the revenue that I made divided by my quantity, right? So I could do that pretty easily, right? I'm just taking total revenue divided by quantity, total revenue divided by quantity. So I can kind of get an idea about what this average revenue is, and it's decreasing as I sell a higher number of units. But I don't care about average revenue, right? I care about marginal revenue. How much additional revenue am I making by selling each additional unit? Well, here I've got quantity increases of 1. When we think about marginal revenue, I can put all the equations over here, so I might as well. We said marginal revenue was just the change in total revenue from a change in quantity. Well, my changes in quantity will all be 1 here. So it's a little bit easier to calculate. So if I sell that first unit, what's my marginal revenue? I went from 0 to 4, so $4. What's the marginal revenue of my selling that fourth unit? Well, there, I increased total revenue from 9 to 10. So the marginal revenue there will only be 1, right? So I can calculate the marginal revenue for each of these different quantities by just what is the change in total revenue divided by, well, what's the number of additional units I sold? Here, the number of additional units for the change in quantity was just 1, so kind of kept it nice and easy. Yeah. Any questions on this? So where that marginal revenue came from?
Will that equation be on the top? Or
yeah, so we kind of had like the visual. Oh, like what I give it to you? Yeah, I'll write it up on the board. I'll write. I won't give you all of these, right? Because we need to be able to think about marginal in our heads. Marginal is always going to be the change, but I want marginal revenue. It's the change in total revenue from a change in quantity. Marginal cost, change in total cost, which over divided by the change in quantity. Right, but I will definitely give you this profit equation. Yeah. So
How do you get that?
yeah, so I'm going to look at the change in total revenue and divide that by whatever the change in the quantity was. So if I'm going from 0 to 1 units, change in quantity was 1, change in total revenue is 4, 4 over 1 is 4. If instead, let's say I had quantities of 10 here, basically it would be the exact same thing, but instead every single time I would take that total revenue, I'd have to divide it by 10 units. Like let's say that first column changed to 0, 10, 20, 30, 40. Well then, yeah, I'm earning an additional $4 going from 0 to 10. But that was $4 spread over 10 units, so that's why the marginal revenue would be 4 over 10. Here I just kept a nice and easy with quantity jumps of 1. So what do we notice about as I decrease the price and increase the quantity I'm selling, what's happening to marginal revenue? It's decreasing. Right? So what ends up being true for the monopolist is that we're thinking about the demand curve they face, that results in also a decreasing marginal revenue curve. Okay? Now, what you'll notice is that price and quantity, that's really just the points that I would use to graph out my demand curve. Right? Demand told me the relationship between price and quantity for consumers. So if I then wanted to graph out my marginal revenue curve here, I would have it at a quantity of 1. It was 4, so they're both kind of starting out at the same point. And then at a quantity of 2, well, I'm seeing only a marginal revenue of 3, all right, so on and so forth. I could graph out that marginal revenue. Now, what will end up being true is that marginal revenue is always twice as steep as whatever the original demand curve was. Now, I'll give you a mathematical explanation as to why in a second, but for now, I'll keep it intuitive, right, or kind of use these numbers to do it. So let's say I had 2 points on this demand curve. So what? 1 at a quantity of 1, that price was $4, and at a quantity of 2, we had $3.50. How can I calculate slope, or in a general equation we kind of call this like y equals mx plus b, right? Or that b kind of represents our slope. So how do I find slope? It's the change in y over change in x, or rise over run is another way of saying that. But all you're really doing is, okay, by going up by 1 unit on the x-axis, so my change in my x was 1, how much did price change Well, it went from 4 to 350, so it fell by 50 cents. So here the slope of my line is just negative 0.5. Everybody with me on that? Just calculating the slope of the line here. Well, what about marginal revenue? Where was I at my marginal revenue curve at that quantity of 1? I was actually at, I forget to where I had this, so let's go from 2 to 3 units here for marginal revenue. So at 2 units, I had marginal revenue of 3. So I can kind of not have to redraw this graph, and then at 3 units, I had a marginal revenue value of 2. All right. So that third unit, we kind of went back to the previous slide. All right. I was adding revenue of 3, changing the quantity of 1. That's kind of where those marginal revenue values come. So if I wanted to do the slope of my marginal revenue curve here, what's the change in my X values going from 2 to 3? So 1. What's the change in my Y values going from 3 to 2? So -1. Notice the slope of my marginal revenue curve is twice as steep as the mean. Okay. Any questions about anything I did mathematically up here from this out? Two ways of thinking. So I think I'll start now trying to relate this to something else that we talked about. So why is marginal revenue kind of decreasing? Well, I'll save it up there in case people are still coming down. So we talked about, and this is, I'm not trying to complicate it, but I think because it's related to something we've already talked about, it might make it a little bit easier, or might make it a little bit easier to understand. So we said that in general, if we kind of remember this, the elastic portion of our demand curve was up at the top, the inelastic portion was at the bottom, right? And what that corresponded to was full revenue initially increasing and then decreasing, all right? So this was how we determined like where is total revenue maximized, is where it was unit elastic. If I was on the elastic portion of my demand curve, well then decreasing the price, increasing quantity was increasing total revenue. If I was on the inelastic portion and I kept decreasing the price, I was actually just driving total revenue down, right? So kind of notice the slope here of total revenue. So it's a little bit, it's not calculus per se, but the slope of a line really represents kind of the change, right? Well, the change in total revenue from a change in quantity is just my marginal revenue, right? How much was total revenue changing from the change in quantity? So the slope of this line kind of represents kind of what's happening to my marginal revenue, right? So my marginal revenue, notice this line is getting flatter and flatter, which is why I'm kind of getting these decreasing marginal revenue values. In fact, we know for sure that once I get past this unit elastic point, if I continue to decrease the price, well, now total revenue is just decreasing. So what would my marginal revenue values be here? Total revenue is decreasing, marginal revenue would be negative, right? Right? Marginal revenue is the change in total revenue. So if total revenue is going down, then the change in total revenue is negative, right? It's decreasing. So any point past where marginal revenue is, or sorry, actually, here's the 0 point. Any quantity where marginal revenue becomes negative, we know that firms will never choose those quantities. Why would they? They just be eating into revenues, and because they're producing more, they're also increasing their costs. So we know for sure that the optimal quantity is going to be somewhere where marginal revenue is positive. And then it's just a matter of, well, what's the relationship of marginal revenue to marginal costs? So I'll come back. I'll jump in kind of a little bit here, and then we'll kind of talk about it more in depth. So just like we had with these perfectly competitive firms, the monopolists, now that we know where their marginal revenue curve is, they're also gonna face some marginal cost. And in fact, the marginal cost curve will just be market supply. Because that one firm's marginal cost curve, their supply decisions, we're the only firm, so that is market supply. So wherever marginal cost hits marginal revenue, that's gonna be the optimal quantity for the monopolist to choose. So they still follow the same rule. They still choose the quantity where marginal cost is equal to marginal revenue, right? It's just that now marginal revenue is not flat, it's kind of downward sloping, and we know it'll be twice as steep as demand. It's a little bit of foreshadowing for what we're doing. If you are a little mathematically minded, I'm going to give you the real reason why, if we have a linear demand curve, why we know that it'll be twice as steep. I showed you with numbers, but I could just cherry pick the numbers, right? So total revenue is price times quantity. I then know that when I'm looking at my demand curve, the relationship between price and quantity can be written out as an equation, right? This is how we have our demand curves. This is where my demand curve starts. This is how much it's decreasing every time I sell an additional unit. Right? This is going backwards. So we've got an equation for demand. Now, usually A and B will be values here, but I'm kind of showing you in general. So what I can do here is, well, I know that the price of the good will follow this equation, right? The relationship of demand is telling me that. So I'm just going to substitute that in here. So this, if I distribute it, becomes A times Q plus B times Q squared. Okay. Now, if I want to find marginal revenue, here we can kind of have this nice, easy change in total revenue over the change in quantity because we have linear demand. If I had any equation, the way that I find the marginal change is I take a derivative. So if you haven't done calculus, that's okay. If you have anything that was close to calculus, maybe you can kind of refer to this word derivative, but you basically would take a derivative of this function, which if I do and I follow those rules, would give me marginal revenue. So when I take a derivative of something in respect to what I can change, here I can change quantity. Think about when I had my marginal revenue equation over there was the change in total revenue over the change in quantity. So how does this equation change when I'm changing quantity? Like I said, if you have a calculus, you don't know derivative rules, it's okay. But basically, anytime you just have something multiplied by quantity, that quantity drops out, so you're left with A. Anytime you have something multiplied by quantity squared, you move the 2 to the front, and you're left with 2 times B times Q. Well, now notice, here's my marginal revenue equation. Here's my demand equation. They start at the same place, but marginal revenue is twice as steep. So that's the mathematical proof of why that occurs. If you haven't had that level of math, it's okay. You don't need to understand it. You won't have to reproduce that. But that is why we know marginal revenue, we can draw it as twice as steep as the demand curve, as long as we have these linear demand curves, which is, I'll keep everything linear here. This gets more complicated if we've got, you know, kind of quadratics, squares, and cubes, things like that. All right, so that was very foreign to you. Don't worry about that. That's more of an explanation if you have some calculus experiences. Just different ways of thinking about this, why we have this downward sloping twice as steep marginal revenue curve. I'm not going to use the icon from this one since I clearly have my animations on. Well, how do we get to this into the pot, right? So if I'm thinking about marginal revenue, I've got these different price quantity combinations, and I've got my total revenue there. Right? If I want to go from 6 to 9 units, how am I getting that marginal revenue of 5? So remember, marginal revenue is what? Change in total. So change in total revenue divided by, not change in price, change in quantity, right? Change in the number of units I'm selling, right? So I increased total revenue going from 6 to 9 units. I increased total revenue by how much? So 63 minus 48. Or what's that, 15? How many units did I increase? Went from 6 to 9, so 3. That's where that marginal revenue of 5 would come from. Okay? So I look at what that change in total revenue was. Divide that by the change in the number of units I was selling, and that gives me that marginal revenue of 5. Any questions on that?
How do we know, is it always gonna be like 63 is minus 48 and 9 is minus 6? Is it
Yeah.
play back?
If it makes it easier. Try to shorthand this. So if you wanted to do change in total revenue over a change in quantity, maybe think about it as of that, where this new quantity and new total revenue will always be the higher quantity value, right? It's always, we're always calculating marginal revenues by like increasing the number of units, right? So here you're always going to use whatever the kind of final or the new quantity and total revenue are, and take the difference between whatever the previous or the old total revenue and total quantity. Or the like, but you can think of it less technically, the line right before it, right? Yeah. Any other questions? We keep moving here. All right, so I already alluded to this a little bit, but we've got our marginal revenue now. We can kind of understand it. That as I increase quantity or decrease the price, right? So as I'm moving down that demand curve, I'm decreasing the price, but increasing quantity. I'm going to have two effects, right? I'm selling things at a lower price, so that's going to eat into my profits, but I'm selling more units, that's going to increase my profits. Well, what point is max? Well, we already talked about that's elasticity. The percentage change in price as I move down the demand curve, let's decrease, that's going to hurt my profits, but that percentage change in quantity is going up, so it's going to help my profits, right? So I kind of have these price and output effects going on at the same time as I move along this demand curve. Right? So if I want to sell a larger quantity, right, I'm going to have to reduce that price. There's a trade-off. It's like everything in life. So when I say that the marginal revenue is always going to be below the price, really what I'm saying here, the price that I can sell things for, well, that's represented to me by my demand curve. Right? Remember, the demand curve reflects marginal benefits. I can charge the price up to whatever someone's marginal benefit is. So the kind of prices that I'm seeing on this demand curve will always be greater than, notice that every single quantity, they're greater than my marginal revenue. And I kind of mentioned, not only are they less than, we know that that curve is twice as steep. So we could see marginal revenue be negative, but I kind of already talked about, led into this idea of elasticity. We know that no firms will ever choose to be at those production levels because they just be having negative margin. Why would they do that? I guess you could choose that, but in practice, we don't see firms doing that. Right? It doesn't make any sense if you're trying to profit maximize. So this is, I kind of jumped the gun earlier with this, but this was just kind of a reminder, right? We think about the elastic portion of the demand curve and the inelastic portion. We know that marginal revenue would be negative for the inelastic portion, positive for the elastic portion. So firms will always choose an optimal quantity somewhere in this range. How do I know that it's going to be somewhere in that range? Well, I'll give you an extreme case. I'll draw it over here. So let's say that I had zero cost. Or at least that my marginal costs were, marginal costs are zero. So I've got my demand curve, my twice as steep marginal revenue curve. And this sounds like it's a wild example, but it's actually pretty applicable to anything that sells tickets. So if you think about like an arena, or you think about a stadium, anything where there's seats. And that number of seats doesn't change, right? That's, you know, they've got the number of seats they do. They pay these huge fixed costs to build this stadium, but their marginal costs to providing more seats, well, stadium just is what it is. It's gonna cost me the same amount to provide one of those seats as it is to provide all of them. They're already there. So when we look at stadium examples, we can actually think about they've got zero marginal costs. Okay. Now, this is the most extreme case. Often we have these kind of more typical increasing marginal costs, but in a scenario where we had zero marginal cost, where would be that quantity that maximized profits? Like I said earlier, it follows the same rule as perfectly competitive firms. Where does marginal revenue hit marginal cost? It will be right at that point where marginal revenue is equal to zero. So even in the most extreme case where I have no costs, I would never choose quantities that were, past this point where marginal revenue is zero, or I would never choose quantities where marginal revenue is negative, or never choose quantities in the last portion of my demand, even if costs are zero. Then as costs increase, well, what's going to happen, even if they just barely increase, well, now my optimal quantity is going to be somewhere a little bit lower, which is going to be, I know that where marginal revenue was zero, this was unit elastic, and then every quantity above that is on the elastic portion of the demand curve. So I know that monopolists will always choose to be somewhere on that elastic portion of the demand curve. And the reason why is because by lowering the price there, I was increasing my total revenues, right? When I have that total revenue curve drawn there. Okay. Question on this. All right, so I already mentioned follows the same rules. We're going to choose the optimal quantity or marginal cost or marginal revenue. I'm saying this a lot, but all the markets we're going to look at, same rule applies. We're going to do that next exam. You've got to have it burned to remember. So once we choose the optimal quantity, how do I figure out what the corresponding optimal price would be? So these firms can determine what the profit maximizing quantity is, but in general, right, that's going to, when I'm selling something in the market, I have to choose the price, right? And then that price is going to be related to how many units I can sell. So what is that going to look like? How can we determine this point? So I'm going to go through, draw an example on the board here, and then I think I've got a couple of slides that might paint it in a slightly different light. But we're going to start out. I've got my demand curve. I've got my twice as steep marginal revenue curve. That's not. And here's my marginal cost. Okay. So where is the profit maximizing quantity? Where marginal cost is equal to marginal revenue. Right? Same idea as what we were doing before for the competitive firms. For every unit I'm selling here, the additional costs way below the additional revenue. So I'm adding more revenue than I am costs, profits are going up. That's going to be true for every single quantity up to this point. So the optimal quantity for the monopolist is going to be at that point when marginal cost is one. Everybody wouldn't have to that point. So what price would they choose? Well, I know that if this is the number of units supplied to the market, once again, whatever I choose to be the optimal quantity, I'm the only person selling this good. So that is the supply in the market. I know if that quantity, last quantity provided, people would be willing to pay up to their marginal benefit. Or the demand curve tells me their marginal benefit, so I know that at that quantity, people will be willing to pay whatever kind of dollar amount this is. So we think about this as the price that the monopolist can charge. Okay. So they first kind of figure out what quantity do I have the marginal revenue being equal to the marginal cost at. Now at that quantity, based off of some estimates I have for the demand for this product, how much are people willing to pay? I know they'll pay, or sorry, how much, what's the additional benefit to consumers? I know people will be willing to pay up to that amount, so I'll set that price wherever I'm at. Yeah.
And then the profit would be
distance between those 2 points?
Yeah, you're jumping the gun a little bit. I can't remember if I have this here. What you asked. It's a little bit harder, right? There's something I haven't put up here yet. So I still have the profit equation over there. What's one thing I don't have from that? Yeah, so I have to get my average total cost curve up here. So we'll do that down the road. It's a little bit trickier, probably than the pretty competitive markets. But yeah, once I've got my price, so got my quantity, the only other thing I need to know is my average total cost. Yep, so we'll use that demand curve to find the price. You know, one thing that we're always going to think about is whatever price that monopolists choose, it's always going to be above their marginal revenue and their marginal costs, right? Whatever marginal revenue and marginal costs are at this point, they're always going to be below the demand curve, right? Or below the price that the monopolist can charge. So for the monopolist, this is good. Think about the additional costs, right? So, another point I want to here, less than the price they charge. Okay, we'll deal with that. It's lower than the demand curve. Marginal revenue is always downward, so sloping twice as steep. These are all things that we kind of covered. Just kind of a summary of those. So I've got this optimal quantity with marginal cost equals marginal revenue. We said we then go through the demand curve to figure out what the price is. So what has to be true for the profit maximizing monopolist? I've already alluded to this, but this price has to be greater than both marginal cost and marginal revenue. The optimal quantity, marginal cost and marginal revenue are the same, but for a monopolist, we know those will be, two values will be below whatever price they can get away with charging. Let's see if I have any, I'll come back from the end of the slide. So I don't really want to go through these. I want to lead to something else. So we'll come back to these, thinking about how we compute kind of profit maximizing points with values from a table as opposed to visually with a graph. So I'll kind of start off Monday's class with that. But I wanted to make a point, I might even go over it again next week. But why are monopolies bad, right? So if I think about the monopolist is the only supplier, so their marginal costs are the only marginal costs that are resulting in choosing this optimal quantity. So their marginal cost, remember supply represents marginal cost, their marginal cost curve is market supply. They're the only supplier that's good. So their decisions based off of their own marginal cost curve, that is the market supply. There's nobody else providing anything. So if this was a perfectly competitive market, right, where would the equilibrium point be? So where does supply equal demand? So if we had a perfectly competitive market, notice the monopolist sets a higher price and produces less. So anytime we have a market that's monopolized, that results in a higher price for consumers and fewer consumers buying that product. Right? So if I have a reduction from this perfectly competitive, allocatively efficient point, and we said in markets in equilibrium, that's where total surplus is maximized. Where's going to be the loss in surplus here? Well, the loss in surplus, we did this before, was the difference between my supply and demand curve for all the units I'm no longer selling. So before, this was only government actions that led to that. Well, if we have market power issues where we have monopolists, we lose out on all that surplus, and because of the monopolists, our society experiences deficit loss. We'll talk a little bit more about the transfer of surplus, why it gets even worse than this, right? It's bad for society, but it's actually even worse for consumers. We can kind of say that consumers are going to be hurt more by this monopolist than the producers are. Intuitively, which makes sense, right? The producer, the monopolist, is going to benefit from this.
Regardless of monopoly, the price
So in the perfectly competitive market, equilibrium price is actually the same. as marginal cost.
Okay.
So if you want to think about it this way, for perfectly competitive, that's a really good question. That, perfectly competitive markets, the price, the marginal, sorry, actually. The price and the marginal cost are the same, but that would be above the marginal revenue. Okay. For the monopolist, that price is above both the marginal cost and the marginal revenue, but under monopolist, those two, I think that means. Okay. Questions? So one more thing I would add, to wrap it up, the reason why that's the case, right? You might think about, well, for the perfectly competitive market, marginal revenue is negative. Why is that the perfectly competitive point? Well, remember, this was the marginal revenue for maximizing profits. In a perfectly competitive market, what are profits? So they get driven down to zero. So that's why if we did have profits of zero, we would be on this portion of the marginal revenue curve that's negative. Right? But if the firm is able to have power to make the decision to not end up down there because they have to be competing with other firms in the long run, the profit maximizing price and quantity will always be lower, price will always be higher. So we'll talk more about monopolies next week. Probably introduce the idea of monopolies and competitive and oligopolies. Other than that, where do you guys get out of here? Because we're a little bit light on people today. And you at least seemed engaged and we're asking some pretty good questions. Any letter today, make it easier on me if everybody answered A, but it's not that big of an issue. Just make sure you get something recorded before you leave today. We'll get another full 10 out of 10 points. Okay. All right. I'll see you guys on Monday. Oh, I also mentioned I will be in my office from 2 to 4 today. Additionally, if you do want to stop by, I did mention that Wednesday, so I want to make sure I didn't forget to mention it.